Hello, hello. Hello, everyone. So we're just starting out in a couple minutes when a bit more people will join. So happy to see that people are joining from this conference. Okay. Okay, let's see. Again, thank you everyone for joining. We'll start in just a few minutes. Just to see that more people are joining. Okay, thank you again. I'm Guy. Hello everyone, Guy Varon from Polymertal here. Talk about additive manufacturing and also how we are going to do this with Polymertal's unique technology, which is taking additive manufacturing to the next level. So that will start very soon. Okay. Okay, let's see. Okay. Thank you for the like. We'll be starting very soon here. I'll be talking about additive manufacturing in the world of the 3D printing along with metallization process of it. That will be the main focus today of how we can utilize this technology to be better than what it is today. And I will give also some information about myself, about the company that I work for, about how we can leverage together and provide the best solutions for this type of technology. And I will just see again. We'll be starting just a couple more minutes till we see a bit more people join. Okay. So, hello everyone, and thank you for joining us today here. I'm Varon. I'm the Business Development Director of Polymertal. I'll be discussing about how 3D printing or additive manufacturing can be utilized to provide best technology that we have with metallization process. So how do we do implementation of both of these together? And yeah, I mean, this is something that has gotten a lot of interest. It's, for what I see, is the next level of additive manufacturing. It's how we utilize it to be even better than it is today. As we know, there are many advantages of additive manufacturing, and I will, of course, discuss most of them. And I think that we can start at this point, and I will do some introduction of myself and the company that I work for, so you'll be able to best know what we do. So if I go back to the additive manufacturing world, I mean, what is, okay. I hope that you can see my screen. So as you can see, I'm Guy from Polymertal. I will be talking about the next level of additive manufacturing, and let's start discussing this. So a little brief about myself. I'm Guy Varon. I'm 33 years old. I'm from Kiryat Motzki in Israel. I'm married with 2 kids. I have a bachelor's degree in industrial engineers from the Technion, the technical school in Israel, in Haifa. It's a school that's qualifying engineers. And I also have an MBA degree that I graduated a few years ago. My main experience comes from automotive and also business unit management. So this is the world that I come from. And today I work in Polymertal. I'll explain about Polymertal quite thoroughly later on in this video and this live stream. And let's discuss a little bit about additive manufacturing. I'm sure you're all pretty much aware of what additive manufacturing is and what it does, but just, you know, a little brief about that. So what are the biggest advantages that we have of additive manufacturing? First of all, it's the speed. It's one of the biggest advantages of the 3D printing that you can do. It's a rapid prototyping. You can get parts from in one day, mainly, if you're connected with the right manufacturer or service bureau or wherever you purchase, or maybe you have one in your office and you just go and print it out. This is one of the biggest advantages. In addition to that, the cost. The cost is something significant. I mean, for small production of parts, and you need just a few parts, and you don't want to mold an injection molder, you cannot CNC manufacture it. 3D printing is probably the most cost-effective way of manufacturing. I mean, for example, I'm doing a marketing kit for my company, and the cost of making that and the speed that I'm able to do that is phenomenal. I mean, I can do it really, really fast and get results very fast. I mean, it's few days and you get the parts in. You know, we usually print in SLS technology. So it's very flexible, very easy to work with. Again, flexibility is the design freedom. You're actually able to do whatever you want in the design. This is like engineer's dream. And I will be talking about this flexibility shortly and how we actually utilize it for this activity. A little bit about competitive advantage. You know, the product's life cycles are reduced. You don't have to wait a long time. You're able to offer something to the market very fast, and you don't have to wait for anything. It doesn't take you weeks or months to get parts in. You're not, you know, moving from development to production in a certain period. It's really fast. I mean, that's a competitive advantage. But if you're utilizing that in your company, then you're in a big advantage. Also, of course, the tangible design and the product testing, you get to touch parts. And I can't express this enough, how much this is important to actually be able to touch a part. So that's another thing that, you know, engineers and business developers and whoever I engage with, they want to touch what I make. You know, I'm a component manufacturer eventually, and I want my customers, my prospects, to feel what I can offer them, and that's one of the biggest added values that my company can give them. In terms of quality, I mean, you can, you know, as an engineer, development, manufacturing engineer, you can actually assemble parts together, and you're able to see that something matches. And, you know, if you've made a design error or something went wrong during the assembly that you could not see on a CAD, then this is, you know, a huge advantage. You reduce your mistakes, fixing time, and you're able to provide a final solution that you can give to your customer or to your systems engineer, and eventually get this rolling pretty fast. In terms of consistency, you know, you get errors in real time. I mean, you don't have to wait until the design is in serial production already and you find some minor mistake. And, you know, fixing it now would be changing a mold or something very complicated that would take a lot of time. This is something that you can do very fast. See your error, fix it, go for a second prototype, and in that case, it's pretty fast and you get very good results. Also, again, risk reduction. This is huge for project managers. You can mitigate design and manufacturing risks pretty easily. And, you know, I used to be a project manager myself. You know, if a designer came up to me and said, hey, I mean, guy, I'm sorry, but, you know, I made a mistake. We need to fix it now. And this was something that it was horrendous. I mean, I would have a headache. I would go to sleep at night with nightmares of what would happen, what I have to tell my customer happened now, that he has to wait a few more weeks or a few more months until he gets the parts that he desired and expected to have on time. But in this case, he was not able to because of a design risk of an engineer. And, you know, you can't come to an engineer with this, I'd say, come to him with many complaints about this. Engineers are people, they make mistakes, it's possible. But how do we mitigate this as project managers? In risk reduction, we're actually able to do that if we have parts being printed as mock-ups or even as first prototypes or first limited serial production, just to see that everything works well. And they can't express how much this is important to everyone involved, all the stakeholders that are involved. So what is our dream? Our dream is to design a part that is lightweight, complex geometry that can replace metal. And, you know, the next level of additive manufacturing that I see, you know, additive manufacturing of parts that are coming from only polymers, they have some disadvantages along with many of their advantages, but these advantages are not enough to most manufacturers to consider these as functional parts. And we do want functional parts at the end of the day for these projects. So we're able to actually bridge a gap between polymers and metals by a metallization process of the polymer. So it's no longer a polymer, it's not a metal, we call it a hybrid part solution. So it's a new breed of parts, something that was not known in the industry, and we're able to provide a solution to our customers by utilizing this type of technology. And I'll explain, you know, again, I mean, in terms of engineers or a project manager or any manufacturer that's or developer that needs a solution, this is something that this type of technology can provide you very high level values that you can never find in traditional manufacturing methods. And I can say that, you know, while engaging new customers and different types of prospects, I've been able to see a lot of advantages coming in. And our customers were, you know, pretty much looking for something innovative to take them out of the mud where they're in, and, you know, where they couldn't find a traditional solution. And even if they went to additive manufacturing, if they were doing it out of polymers, it was usually not strong enough. It was not thermally conductive. It didn't heat, you know, no heat conductivity. So it was isolating. So And also in terms of strength, it was never good enough for them, or they would have to go to the very high level of polymers in 3D printing, which is not fitting everyone's budget. And on the other side, if they were trying to go to additive manufacturing of metals, which is, I think, light years, light years behind the additive manufacturing of polymers. So this was something that, in terms of budget-wise, it was horrendous. I mean, getting a small 3D printed part from metal would cost hundreds of dollars easily, and sometimes it's in thousands of dollars, depending on the size of it. And it's a pretty complex manufacturing process. So let's start talking about Polymertal. Polymertal, and I'll explain what Polymertal does and what solution is offered and how this technology even works. I mean, this is something amazing that I'm sure you'll be interested in. So who is Polymertal? Actually, Polymertal is actually an innovative Israeli company. So we're located here in Israel, in the northern part of it, in Haifa. Whoever knows or visited Israel before. And we're able to provide hybrid part solution for manufacturers that need some very, I'd say, high-level applications, something special. I mean, we're not going for the mainstream. We do not do, like, for the VW Golf 1 million parts a year. This is not something that I think is within our I'd say main objectives. We applied actually the deep chemical surface etching technology to make the polymer platable. This is a part of the process, which I'll explain a little bit more about further in this presentation. And our vision is to become the world-leading supplier of these high-value hybrid parts. So what are these challenges that we're talking about? What is it that makes engineers not sleep at night and sheds these sleeping hours from them because they're not able to find a solution for? So the product's design, the manufacturing process is becoming more and more complex. So I can say that over several years that I've seen back, is the requirements are always getting harsher. They never go back. They never become easier. You never get relaxations of the design and requirements from your customers. So the products today have to be much more lightweight, specifically in vehicles or in aerospace or in space. Anything that flies or drives needs to be lighter. There's the complex 3D structures that, today within wherever you're designing, it's pretty complex to fit in your part. There are always other parts interacting with it. You're looking for those metallic properties, the strength, the electrical conductivity, and also sustainability. I mean, think about it. Sustainability today has become something huge. I mean, this is, I can say, one of the things that makes the world change these days, climate change, and every company that respects itself is looking for a sustainable solution to its products. And there's, today countries have their carbon footprint. So this is something very, very important in today's industry. And our company is looking into that through the technology that Polymertal is offering. So in addition to that, durability, I mean, you want your parts to hold, right? You don't want it to break after first or second time. This has to be durable over time, both mechanically, thermally, and above all, it has to remain at a low price. I mean, nobody wants to pay huge amounts of dollars for something that's not worth it. So as we see, these new products face contradictory requirements. I mean, they're if you think about it, it's almost impossible to do that. So how do we do that? The challenge is not answered by the existing solutions. So metals, for example, are heavy. They're limited support for the complex geometries unless you go to 3D printing, which again is 10 times, I think, everyone's budget. It's it's very high energy process, so again, not very sustainable, and it's limited global availability. It's not all over the world, and you cannot get whatever you want wherever you want. And polymers themselves also are lacking electrical conductivity. So EMI, RFI shielding is something that the polymer by itself cannot do. Absorb humidity, again, not something that is feasible. And they do not transfer heat. Polymers are pretty much isolating everything. They do not meet the strength requirements. Again, a lot of my customers are coming to me and saying, "Hey, Guy, I mean, we have this great 3D printed part, but it's not strong enough. We cannot use it for any application. Not something functional. Definitely not chassis or any structure component. Not even on a side of a structure or anything like that." So this is a big issue today. The strength of the 3D printed part. And also sensitivity to chemicals. So, wherever you are, if it's in a vehicle, in an oil system, or any abrasive fluids that are, interacting with the material, you don't want it to go and break off the material. So generally, you really want to be on the high end of this area. So we see metals and polymers do not solve the challenges, and composites are also, again, expensive, limited in geometry. They are not environmentally friendly. Many, I've seen composites being used, and I'm not saying that they're bad or anything, but I don't see them as the future. I see that they're not answering some of the biggest needs in the industry, which is, again, the sustainability, the geometrical complexities that are not answered. So again, this is not something that can work. Wood, ceramics, or any alternative technologies, again, I'm not going to go too much into that, but they do not also solve the challenges that we're facing. So what is actually a polymertal solution? We're able to obtain the optimal properties that you need in one single part. And how do we do that? Okay, so for example, if you want the high strength and the low weight, this is something that would almost never be able to be within one part. The thermal conductivity or the heat isolation, this is, again, something that we cannot do without, a special technology. Electrical conductivity and vibration damping and prevention of the moisture penetration while still maintaining the fewer parts per assembly. So again, integration of these assemblies is something phenomenal. I mean, I've seen people that are not aware too much of the additive manufacturing world coming and saying, "Hey, I mean, how do you actually do all these components, like 30 different parts, into one or two parts?" So this is one thing to keep in mind. And I mean, how do we do that? We're using 3D printed plastic parts, and we do the metallic plating. So it sounds easy. It is easy once you get into that. And this is something that we're able to offer to the world. It's not, I'd say, a world-renowned technology that everyone knows about. But it is something that you should definitely consider as a solution between two different areas of the metal and the polymers. So this is like I always go. This is like the iPad that gave a solution to something in between two areas. So the iPhone and the MacBook, there was nothing always in the middle that could, the phone was too small, or you cannot use it really as a computer. The laptop, you have to carry it out everywhere. You have a charger, you have, it's pretty big. The iPad gave a solution. This is where we're seeing ourselves as the iPad of this industry, this huge industry. So our solution, I mean, how does the solution actually work? So we take the base polymer or the polymer skeleton, and we take the metal, and we combine the best of two worlds. Okay, so we take from the polymer, we take the low weight, the few required parts from the additive manufacturing, the heat isolation, the vibration shock damping, and all these together, are the biggest advantages that we have in polymers. So, all of you out there who are, using polymers as in additive manufacturing, these are great features. I mean, you guys, have this as a solution. It gives you a lot of advantages versus traditional, I'd say, applications. And what we do in Polymertal is we take also the additive manufacturing into the next level, and we take the metal world and make it something that's very interesting. So we take the electrical conductivity and thermal conductivity from the metal. We take the strength. Okay, this is an important feature, and the prevention of moisture penetration. Again, metals, as we know, they do not get any of those fluids penetrated. So this is very important in many applications, specifically fluid systems. I've been seeing a lot of requirements going there. So these are the ultimate combinations in one single part. We're able to actually provide this in one piece. So this is very important. So how does the value proposition work? I mean, what do we do in Polymertal that's so special? So we're able to do the weight reduction of up to 60% weight reduction. The production time is reduced by 50%. You don't have to assemble all these parts together. It's very important. You know, customers are looking for systems. They don't want to start assembling in their line. That costs them money, and they don't want that to happen. They just want to get a finished parts as easy and fast as possible. Again, additive manufacturing gives a lot of that world. And as I said, the number of parts that we have per component is reduced. We can reduce it by 80%. Even we've had even higher numbers than that. But in most cases, again, integration of components into one part is huge advantage. Huge advantage. Design freedom for complex geometries, again, super important for complex geometries. As you can see here in the middle, this is 7 parts. That used to weigh 1.2 kilograms. Now it's one part, only 0.36 kilograms. You know, this is huge. I mean, when you hold it in your hand, you know, if you held the previous part, the previous design part in your hand, and then you have this other part, you cannot believe that this is answering the same needs. Again, sustainability, carbon-free material, recycled materials, low energy process. I mean, what more can you ask in terms of sustainability? And again, we're combining all these conflicting properties. So what is the technology? I mean, how does Polymertal actually do this? So Polymertal's technology is actually direct metallization plating. So Polymertal's innovation is a chemical surface etching technology. We do metal layers of over substrates. So we have the base polymers. Okay, sorry about that. So we have the substrate polymer, which is also something. Okay, so we have the substrate material polymer, which is coming from 3D printing. And on top of that, what we do is we do our innovative process. We do the chemical surface etching technology. This is a huge advantage. So once we do this surface etching technology, we create actually nanopores on the surface. That's what's able to create this adhesion between the polymer and the metal. So the electroless metal layer that we use is copper. Okay, so copper is one of the best conductors in the world. It's a pure chemical process creating excellent adhesion between metal and polymer. We're already doing over 100 different polymers, including several types of ceramics, which has also grown some interest. So after the electroless metal layer, so we have a copper, we actually thicken that. And again, it's only, if you think about it, it's pretty interesting. I mean, we're able to do that in only a few microns, and we have this first layer. It's amazing. I mean, I've before I came to the company, I didn't actually know how this works, but now we have this very thin layer that's making a huge impact, and it all starts with the copper layer. And on top of that, there's the nickel layer. So that's the outer layer. Again, it's an anti-corrosive material, very hard material. Again, giving it mechanical strength. And also silver, tin, chrome, and gold. These are also some of these final layers that we have for metal. So again, this is, we don't use any primers or glue here. And this has been a proven technology in high-end products. Sorry, just 1 second. Okay, so let's go on. So Polymertal technology, we're also very involved in R&D projects. So we have titanium plating, Polymertal 1.8 million euro grants from the European Union for developing of unique titanium plating over polymers. Again, this is a 2-year program. This is something that we're currently doing, and this is going to be used for medical devices, probably to use as a replacement of body parts or implants. So very interesting. Keep following us, and you'll be able to see a lot of that going forward. Our technology validation. So again, we have mature, repeatable, multi-year orders from some of the elite customers. We have Porsche online. We have Ryzen 2020 as a key factor here. We have also Israeli companies that are buying from us, and we're already started some of our activities abroad. So a lot of different interests from customers, specifically in Europe and the United States. That's our main markets and our target markets. So our assets, as you know, we have over, I said, 100 different chemical surface etching processes for polymers and ceramics. We have intellectual properties of trade secrets and patents to protect our technology. Again, it's unique. It's something that leverages, and we're able to offer it to the world, but we have to keep it safe and not to have anyone try to grab it from us. So that's very important. So 3D printed polymer surface treatments on 3D parts. Again, that's our main aim, and we're working with well-known companies both in Israel and abroad. And our growth strategy is implementing this technology in different verticals in Europe and the United States. So that's a lot of what we do. For sustainability, as I said, this is something that's huge. I mean, every company is looking for that, and I can definitely say that we make production and design more effective as well as sustainable. So this is very, very crucial. We don't use any carbon into our material, not the base polymer, not the metallic layer, of course. So as you can see here, we're reducing the carbon footprint of 40% per kilogram with the hybrid components. We have, I'd say, we've done also sustainability research, and if you want and if you're interested, I can definitely send this to you for further investigation going forward. But overall, this is a very clean technology. So we're very responsible and determined. We're always looking how to improve. We're actually engaging in a new project on how to further improve the base polymer to be super sustainable, so that will even further grow our reach for these types of applications. So I will talk a little bit about the proven technology and the manufacturing of Polymertal. So we have different projects, different use cases that we've done. We have waveguide project. Again, waveguide is a communication device that's being used either in 5G networks or other communications, like satellites or these types of applications. We are also working on some space applications. Again, these are the high-end, I'd say, applications that we're currently engaging with. So replacing metal satellite parts with our hybrid parts. We are always also supported by the Israeli Space Agency. Our production process is also going automatic. So up to today, we've done everything manual, but right now we're in a project of deploying automatic production process. We're working also with U.S.-Israel cooperation of binational programs for development. Space Florida project, and it's supported by the government in Florida. We're also open for other research projects. So if you have something that you think that we can work together on research, we're also very focused on that. And there are different grant plans that we are applying for with these types of programs. So, I mean, feel free to contact me on these types of development programs that you think might be interesting to work on, and we can get a grant of development together and at least cover some of the expenses on these. So production, in terms of production, we have innovative production processes. So everything, as you can see on the right, this is the production process that we have here. It's eco-friendly, it's energy efficient, it's scalable, low construction cost, and everything is compliant with ROHS standard. Again, something phenomenal. I mean, this is something that you know, is easily put wherever we want. So we are also looking at our first production site outside of Israel. So we're looking to do that either in Germany, in the United States, maybe somewhere else in Europe. Again, it depends on where the majority of the sales is going to be in 2022. So 2021 is the year that we're thinking of, you know, and seeing how the market is reacting to our technology, where we get the highest number of sales from, and this is something that we'll go forward with. Our leadership team right now, Islam Karmeli, he's the CEO coming from the Israeli Air Force, and also has been the COO of an aeronautics leading UAV company. We have Yair Safai, he's the executive chairman that we have. He's coming from the world of VCs. Sabina Efraimov, she has a PhD in chemical engineering, you know, specifically in treatments of polymers, and she led the chemistry lab in the Technion for the past 7 years before joining Polymertal. She's already with the company for about 6 years. And I'm the business development director. I'm coming from, as I said, the automotive world, from the OEM suppliers. I have international customers program manager experience. I come from aerospace component supplier, so I have a lot of experience in the automotive and aerospace world. I'd go with a couple of case studies. So we have an automotive oil tank. This is one, I think, great example of how you utilize additive manufacturing into the world of hybrid components, and how you can work with that in the, I'd say, super high requirements of customers. So, you know, our customer came to us with harsh technical requirements, high G-forces, uncompromising quality, endurance was, you know, having high temperature oils. And this is, you know, this is a pretty serious system that we have to, you know, find a solution for. It used to be from composite parts. So that's the old design. As I said, composites, I don't believe in them as being the future. And yeah, a little bit of light here. It's too dark for me right now. Again, we wanted also to minimize the weight. Again, weight reduction, super critical. We're able to reduce the weight by about 35%, from almost 2 kilograms to 1.25 kilograms. And this is again, composites. So this is not even metal. I mean, we'll be able to reduce the weight of the part even after metallization significantly. And this is something, you know, phenomenal from our point of view. And this is also sustainable. We're replacing a polluting composite part that's carbon, you know, it has lots of carbon additives in it. And to, you know, do it from recycled materials and, you know, just plate it with our metallization process. It was used to be 30 different components in this assembly. You can see maybe some of the parts there. But we are able to do it from a total of 2 components. So again, super interesting from us. So we do the full design and production at Polymertal. Again, this is our core competence, and this is something very interesting. So again, from our customer's point of view, I'm referencing now a little bit of backwards, but this is something, amazing. He came to us with something that didn't exist before, and we're able to make it completely new, redesign it, give a lot of design freedom. Specifically, this was engineered by us, so we did all the design of the metallized part, because you have to take care of some aspects. And he got a pretty interesting solution. He's pretty happy with this type of solution now, going from the previous old design that you've seen, and also being able to save on cost, reducing cost by 10%. Again, that's money, out-of-pocket money, that we're able to save him. So again, from our point of view, this was an amazing offering to the customer. We also do manifolds, so you can see there are different alternatives for these manifolds. You can do it from polymers like PA12, 3D printing, but it doesn't transfer heat, so it's not a good manifold. And after our metallization, you can see it's 68 grams, as only adding about 23 grams to the overall weight of the polymer, but this is a pretty thick layer, yeah. The metallic option of it was actually 150 grams. So we're able to do it in one part, make it transfer heat, minimizing the weight, and reducing the price. Again, super critical, super interesting. Also, a manifold is something that's being used everywhere. You can think of using it in automotive, in aerospace, and in anything where there's need to be a interesting heat transfer between components. Again, we're also in the satellites world. So, for example, nanosatellites, CubeSat. Some of you know it is being known like that. The product requirements are, of course, lowest weight possible when you send something out to space. There's the launch rates, which are pretty high, and whatever weight you save is money eventually that the company pays to get that satellite into space. Of course, minimizing the number of parts. You don't have to do an assembly, and also outgassing approval. Again, super critical for space. And you can see here that we were able to actually save on weight by, again, using polymer that's metallized, decreasing the production time by 90%. Again, this is a complicated design. We're able to do it very fast, and also reducing the cost. You can see it used to cost $2,700. We're able to offer it for $500. Weight significantly reduced, as you can see. It's only 68 grams versus 190 grams in the original design. And this was 12 different parts, which we were able to do out of one. So you can see, again, also for space applications, this is something very interesting. Great solution that we can use. Also for aviation, we have a F-35 pilot helmet application. When you're a pilot and you're wearing a helmet, you want it to be the lowest possible weight, because otherwise the pilot's getting tired of having something heavy on his head. So again, this was something that the company that came to us, it was very important for them to minimize the weight. So there's also EMI or RFI shielding. So for those of you who know, electromagnetic interference is shielding per mil standard of 8110 F. And the production reliability, of course, this has to be reliable over time. This is something that's being used in aviation. We are already 3 years into this program with repeatable orders. Our customer tried to find another source, because being only one technology, one source, that's a risk. To find something either in the United States, in Israel, but they weren't able to find that. And this is, again, something that's going to the Lockheed Martin F-35 pilot helmets. Okay, that's about it, guys. I've tried to explain as much as I can in short time about what Polymertal does, how we're able to give solutions to different aspects in additive manufacturing. I see that additive manufacturing is one of the biggest trends going forward. It's replacing all technologies, and with our unique solution of using metallized polymers we're able to provide hybrid parts. These hybrid parts are huge in potential, and I can say that it's been amazing working and finding different applications that these can be used, from the very small, simple ones to the super big, complex space automotive applications. We're active in many verticals, so feel free to contact us. My email is here, and I will send contact information as well to contact me either by email, phone. You can reach our website. We're active on LinkedIn. We post, so please access our LinkedIn page, and you can see whatever we're doing. And we're posting any new technologies, new applications, some of new product portfolios that we're offering to the market. So thank you all for listening. And I'd like to say that we're the best-in-class supplier of these high-value, lightweight, and environmentally friendly parts. So contact us, leave your comments below, like and subscribe to our channel. We'll be posting new things going forward. So thank you everyone for listening, and have a good afternoon, morning, wherever you are at.